Go. Yep. Hi, I think it's just time to get started. So firstly, thanks a lot for taking the time to attend this session. And I hope all of you had a great start to the event or to the week. There were some tremendous innovations that were announced in the keynote. Hopefully some of us got to go to the foundation session as well. So all in all, hopefully a good start to the week and hopefully a good evening party as well. This session is about providing a click down of the networking pieces and how, through the magic of Windows Server and System Center, we are enabling software-defined networking, and hopefully you will see how this can help you in your data center transformation initiatives. For a quick introduction to myself, my name is Anant Sundaram, and I'm part of the Windows Server and System Center product marketing team. My co-presenters are sitting here. There's CJ Williams, who is part of the core Windows network engineering team at Microsoft, and then Dhananjay Mahajan, who is the partner technical program manager, and he'll certainly be representing the ecosystem view into our all-up software-defined networking solution. So hopefully this should be a good discussion. We will certainly be available for Q&A after the session. If we find time during, we can even take questions. There are mics as well, and feel free to step up and ask any questions that you think you might need more additional information on. Okay, with that, I am going to just set some more context on session objectives and takeaways. So the first session objective is you guys would have heard a lot of buzz around SDN and what it means, what it does not, and so on and so forth. It's clear that it's still early days in this, but we want to make sure that we clarify how we think SDN would fit in to your data center transformation initiatives. That's job number one. The second piece is we will actually define our approach and the governing principles that we are using in delivering our SDN solution to you. And then the last piece would be we want to provide you an overview of the key technologies that make up our solutions, including all the valuable work that our partners are doing with us. And if we do our job well, there are three things that all of you should sort of take away from this presentation. The first one is you'll see that our SDN approach is deeply informed by our cloud-first principles. And the fact that we are getting a lot of our learnings on delivering SDN through operating a large-scale data centers and networks in our own data centers. The second thing is Windows Server and System Center has an inbox solution that you can deploy today. And it should, or our promise, or we believe, is that it should have all the core components of an SDN solution. And then the third thing is we are committed to make sure that we take an open and extensible approach and make sure that we are building our solutions to standards so that you can carry forward what you have, and our partners can actually make sure that their unique hardware capabilities are exposed through our solution as well, right? So if you feel free to actually share your questions or thoughts as we go through this presentation. And hopefully we can help clarify and make sure that we've met those objectives as well. Before we actually get into the networking specifics, it's important to understand how SDN fits into your overall, context around data center transformation, right? Brad spoke at the keynote yesterday about CloudOS and how transform the data center is core. Is one of the core pillars to enable our vision around CloudOS. So there are three things that sort of, that we think we are hearing consistently from you folks that informs our approach here around data center transformation. The first one is you're saying, hey, we need the ability to access infrastructure capacity on demand and scale it flexibly as per my business needs, and I shouldn't have to think or care about where that infrastructure actually sits. So it's less about whether the infrastructure is on my premises or elsewhere, but all I want is to make sure that I have infrastructure that is seamlessly available to support my business needs. The second piece is, and this comes up consistently, where we've heard a lot of you say, gosh, our IT budgets are flat, are shrinking in many cases, and we are sort of spending a lot of our time just keeping the trains running, just get rid of the complexity associated with keeping our trains running so that we can do more impactful work. And then the third thing is, just this notion of speed and agility, and this comes up always, right? As long as you're meeting the first and second. The third goal seems to be the most important one in terms of uniquely differentiating the services that IT offers by enabling that speed and agility that your business needs. Right? So these are the three themes or feedback elements that we are hearing in the context of this discussion. And we say that we have three tenets, our approaches to sort of transforming your data center through our products and capabilities. So the first thing is this notion of data center without boundaries, and this basically speaks to that infrastructure on demand request that you folks had. And what this means is that you shouldn't have to care about whether the infrastructure is in your data center or in Windows Azure or at a service provider data center. The reason is that we believe Windows Server and System Center have this common thread of virtualization and management technologies that can extend through these data centers and enable you to extend your data center capacity in turn, right? So for example, if you think about just fundamentally virtualization, right? It's the exact same hypervisor technology that runs in Windows Server as well as in Windows Azure, right? So irrespective of where your virtualization infrastructure is, you can easily extend your data center on demand using our virtualization platform and management system center. The second piece is around cloud innovation everywhere, and this is again fundamental to our philosophy that I was saying earlier, where we are going to infuse innovation from our learnings into things like storage, like networking, like disaster recovery, and you saw some of that yesterday as well. The third piece is around dynamic application delivery. And if we do these first two infrastructure things, then the third thing is easier because you have that underlying flexible pool of infrastructure. It is hopefully simple enough and low cost enough that we've infused the innovation of the cloud, and that allows IT to actually deliver a rapid response, that speed and agility which the business is looking for, right? So this is how we sort of think about transforming the data center and a set of capabilities in Windows Server and System Center. And as you go through the rest of the presentation, you'll see how this connects back into networking specifically, but also how networking all up supports our Transform the Data Center initiative. So, so I spoke about this previously as well, where I said we have this cloud-first philosophy, and the fact that we've got 200-plus global online services running in our data centers just creates this sort of virtuous learning cycle between what we run in our own public clouds, if you will, and what we offer you through our capabilities in Windows Server and System Center. I mean, the biggest feedback or question that I get is, when will we get Windows Azure-like capabilities, right? And we are actually making a lot of this come real. And by the way, no one else in the industry can claim this because no one else has the investment here and there. And the fact that we're able to link this is unique for Microsoft. Specifically, if you make it real, we actually have already done or bought a lot of these learnings and approaches and baked them into Windows Server 2012 and System Center 2012, right? If you think about storage, for an example, and if you sort of walk into a big Microsoft data center, let's say in Chicago, you'll find that we are basically using direct attached storage, and a lot of the intelligence is built into software, right? So it's just a bunch of industry standard disk, direct attached, into a blob. And a lot of the things like replication or resiliency or performance is built into software. So with Windows Server 2012, what we did was we actually got that high performance based on industry standard hardware to you folks. Things like you saw yesterday with storage spaces where we sort of drove up IOPS per dollar to a crazy amount, right? And then we are able to sort of seamlessly fail over your apps, again, on low-cost industry standard hardware using technologies like storage spaces. So you can easily deploy SQL or Hyper-V or those kind of critical workloads using these low-cost technologies. And then we have the notion of multi-tenancy with isolation. So if you think about Windows Azure for a moment, we are adding 1,000 customers a day. And a lot of them are actually enterprises who are trusting Windows Azure and extending their data centers into Windows Azure, right? So what we have to ensure through Windows Azure is, one, that customers can trust that their data is not going to be mixed with other customers' data, right? At the end of the day, Windows Azure is this massive shared platform that we offer, right? So multi-tenancy is a given there, right? And the isolation is also a given. And the next piece is we've got to ensure that customers can easily onboard themselves into Windows Azure, and we've got to provide them that flexibility in getting their own IP address spaces, for example, right? So we're doing a lot of that in Azure today already. The third thing I'll talk about is automation, right? And we make tens of thousands of changes to the network alone in Azure from a provisioning and a reconfiguration standpoint based on what customers are trying to do. And we would absolutely fail if we didn't have a level of software-enabled automation and control in Windows Azure. So a lot of those things is what we are delivering to you. For example, in Windows Server 2012 and System Center 2012, we delivered Hyper-V network virtualization along with the ability to manage those underlying networks as well. And we'll talk more about that. But the point here is that we absolutely think that we've got something unique here in our ability to actually bring you our learnings directly through our software. And I also want to encourage you to think about using the public cloud as your benchmark. Brad also mentioned this yesterday, right? Because we are driving to make sure that our on-premises offerings are built to this cloud-first benchmark. And we really encourage you to do that as well, because that is, the public cloud is where you can achieve the maximum agility and the cost benefits that your business might be looking to you to deliver. So I just set this context just so that you get the basic philosophy that we are driving to. But I did want to sort of zoom in a little bit more and make it more real in the context of networking and in your context as an enterprise or maybe a few service providers as well. So then what are those requirements to transform networking and in the context of supporting your overall data center transformation initiatives, right? So the first one we think is about just looking at networking or looking at delivering networking as part of this pooled infrastructure resource pool. Sorry. So what that basically means is that you should be able to think about your network, your virtualized network, just like you think about server virtualization, right? So with server virtualization, what you basically did was abstract your compute resources or server resources from the underlying hardware and then deliver them as a pooled set of resources. A lot of you, I'm sure, have consolidated a lot of your server infrastructure. In many cases, you're even doing things like live migration, right? But if I stop you for a moment and think, as you're doing that live migration, do your IP addresses move or migrate as smoothly as the compute resource? And the answer in many cases is no, right? I mean, if you've ever tried to migrate an application from one point in your data center to another, then in many cases, networks tend to be the barrier to doing that. And why is that the case? Because the network is still monolithic. Things are still physically and manually stitched together, right? Be it your ports, your switches, your routers. Things still happen one device at a time. So we think, similar to server virtualization, it's a no-brainer to deliver networking in a pooled, automated manner. And we absolutely need to offer that capability or deliver that requirement to you folks. The next piece is, even as you're thinking of pooling your network resources, you still need that multi-tenant isolation, scale, and performance. The reason is that a lot of you are telling us that, hey, we are already beginning to have a service provider's mentality even as we deliver internal IT services, right? For example, the ability to isolate your different line of business units, right, like marketing or finance or HR, right, and making sure that there is a level of isolation and isolation even as you are delivering them on a shared pool of a network infrastructure. The next piece is around scale, right? If you think of primitives like VLAN, yes, they were useful up to a point, but then they will quickly run out even as you're trying to build out your private clouds, for example, right? And finally, in doing all this, you want to make sure that you have a level of performance and you don't sort of compromise on that, right? And having a level of control on the traffic flows and guaranteeing quality of service, even as you're sort of trying to do the shared infrastructure and multi-tenancy with isolation. The third piece is expanding data center capacity seamlessly, right? Think of a scenario where, for example, your organization acquired a third-party company, how easy or how difficult actually is it to integrate their infrastructure into yours, right? Integrate their network infrastructure into yours, right? That's a scenario where you want to make sure there is a level of seamlessness in that process. Or conversely, if you are trying to extend your data center to a service provider like Windows Azure, you want to make sure that you have absolutely all the flexibility to bring your own IP to that and extend your data center in a seamless fashion, right? Again, some requirements which are not fully met today. And finally, the final frontier is just operational complexity or operational ease, right? Today, a lot of network operations are still manual, right? A lot of folks, whenever there is a move, add, change requirement, people create a trouble ticket, it goes to a network admin, and then a lot of folks get back and forth before the actual changes are implemented, and the clock keeps ticking. So we still see that there is a lot of opportunity there. And one of the fundamental reasons why operational complexity is an issue is that the control plane, or a lot of it, resides in the device itself, right? So at best, you are sort of talking about a single device configuration or provisioning at a time. And when you think of concepts like the cloud, you want to make sure that you can do these things at scale. And we have to make sure that the right information surfaces in the right consoles, so you have a level of centralized automation and control. So again, a lot of opportunity to sort of transform the network here through these 4 requirement areas. And hopefully these make sense and they sort of resonate with what you're seeing as well. So then, how do we as Microsoft define software-defined networking, right, to meet those requirements that we spoke about earlier? We think fundamentally it's about enabling software to manage the network in the context of your apps and workloads, right, or virtualized apps and workloads, right, to be more precise. And for that, you need 3 fundamental capabilities or mechanisms. Let me put it if I put it that way. And the first mechanism is something that can help abstract your physical network from the virtual, from your applications and workloads, right? And this goes back to what I was saying about things being so monolithic and tightly integrated today. So to understand why this abstraction represents a breakthrough, it might be instructive to go back to why server virtualization took off, right? It took off because on the one hand, it did certainly abstract the compute resources through a layer of software, but most importantly, it did it in a way that was transparent to the OS and the applications that were running on top, right? So if the OS and the application was seeing a CPU and memory, they now see a virtual CPU and virtual memory. So those abstractions were retained even as you introduced that slice of software in between, right? So it was important because that basically retained people's knowledge or thinking, or it fooled the application or the OS into believing that nothing had changed, and they basically had the hardware resource to themselves. What that also helped us as IT pros is actually do the exact same things with a virtual machine as you would do with a server, right? You provision a VM, you migrate a VM, you snapshot a VM. All of those things are things that you used to do with your servers. Similarly, we think we need a mechanism to virtualize the network and abstract it from the underlying physical network infrastructure. And what that basically means is that you need similar abstractions. Like, so if you have a physical switch, you need a logical switch or a virtual switch. If you have a physical IP, you need a virtual IP. In other words, retaining the exact same abstractions and the same set of operational commands that you would normally associate with network gear, but done in software and manageable at scale, right? So that's the first mechanism. The second piece is you need a way to centrally, again, once you've abstracted your underlying physical network from your apps and workloads, you need a way to sort of manage all of this at scale and manage all those virtual network infrastructures at scale with a certain level of automation and control. So what you basically need is a mechanism that helps you define policies centrally to manage those virtual networks, and when workloads are instantiated or moved, those policies also update themselves automatically, right? So that's the second piece. And once you've defined those policies and you know that they can readjust themselves automatically, you have the ability then, or you need the ability then to control data center flow. So you need to be able to say that, hey, for this, these types of apps and workloads, I need a certain level of guaranteed network traffic bandwidth, right? The ability to specify those things and control all of that in software. So these are the three things that enable you or enable software to dynamically manage the network in the context of your apps and workloads, right? So that's how we scope and define HDN. And what we did with System Center 2012 SP1 and Windows Server 2012 is that we defined, we delivered a lot of what I just said earlier. To the left here is what we think are the core promises of software-defined networking. And I used all of these terms earlier as well, right? Flexibility, automation, and control. So hopefully this is not anything of a surprise by this point, right? And we have all of these technologies that we delivered in Server 12 and System Center 12 SP1. So for example, Hyper-V network virtualization provided that abstraction mechanism that I was talking about earlier, right? And the flexibility that came with that. If you looked at System Center Virtual Machine Manager, it offered that mechanism to actually manage these virtual networks at scale. And it enabled you to do that with a level of control that you could manage your data center traffic. Then you have the Hyper-V extensible switch, which actually allowed partners to build security and manageability extensions on top of our platform. So again, a great example of how we enable control. And like I said, partners are building extensions not only to the switch, but across the stack to enable all of these promises that we have here. So hopefully it's sort of connecting back for you folks from where I started. And then there are three principles or things that we think will be true even as we build more and more capability into our products, right? With R2 and into the future. And those three things are these, the bottom. One is we absolutely think that we will continue to be open and extensible. We think our partner ecosystem is super critical to enable the full promise of software-defined networking. We also want to make sure that we are doing it in a way that is standards-based versus making it proprietary. We also recently enrolled as platinum sponsors for the Open Daylight Initiative, which is, again, a broad industry consortium to standardize interfaces at all points in the networking stack between the physical network infrastructure and the virtualized network infrastructure and the apps on top. So we did a lot of good, we anticipate doing a lot of good work there. The second piece is around being built and production ready, right? A lot of the stuff that I'm talking about is built into our software, right? So you don't need to actually acquire additional management tools or licenses or third-party products. You can actually do a lot of this stuff with Server 12 and System Center 2012 SP1. We also have done a bunch of extensive tests to make sure that this software is production ready and you can deploy it today. The third piece is important to understand as well. We believe that the full promise of HDN is going to be delivered by hardware and software in combination. There's a lot of talk in the industry around, gosh, is hardware going to be commoditized, or are all networks going to be flattened, and so on and so forth? We believe that that's not going to be the case, very likely. And we want to make sure that partners can continue to expose their differentiated hardware capabilities to us. We also realize that there is a level of native performance that the chipset can only deliver, and it's very difficult for software to go that absolute last mile. And we are sort of committed to continue to work with our partners to make sure that we surface this joint innovation between hardware and software as part of our HDN solutions. So we've seen a lot of customer and analyst excitement, frankly. I mean, there was tremendous reception to these products that we delivered. And specifically, you see that that we have customers who are actually deploying some of these capabilities today in production. Empire CLS is a car fleet reservation company based in New Jersey, and this is their CIO talking about Hyper-V network virtualization. We also commissioned and did a study with Forrester where, again, software-defined networking capabilities were core to the ROI that Windows Server 2012 promises. So again, great, tremendous customer and analyst excitement, and like Dhananjay is going to speak later, tremendous partner momentum as well, which is clear indication of the momentum that our products and solutions have in this space. So then you might say, okay, I get that you guys delivered strong pieces of your HDN solution in Windows Server 2012 and System Center 2012 SP1. So what's new in R2, right? And I suspect some of you would have heard pieces of it yesterday, but I want to call out two big pieces that we've added in System Center 2012 R2, and Windows Server 2012 R2. The first one is this notion of software gateways. And this is actually in response to the tons of feedback that we got from a lot of you. A lot of you told us, gosh, you guys have offered a fantastic network board platform, and I'm beginning to virtualize my network, but I need additional help in making sure that I can connect parts of my non-virtual networks to my virtual network infrastructure. So, right, I've got some pieces of my network which are still physical, some pieces are virtual, so I want to connect them and make them talk. I also want to make sure that I can talk to the external world because I've got some stuff at a service provider and I want to seamlessly extend my data center to a service provider. And it turns out that we need a level of translation to make that happen. So we are super excited to announce that we are delivering in-box software gateways that will enable that translation. So think of this as unlocking a ton of hybrid IT or hybrid networking scenarios. And we look forward to you guys working with us on test driving these software gateways and making those hybrid networking scenarios come real for you. We'll talk more about that in the later part of this presentation. The second piece is around network switch management. And what this basically means is we are providing the ability to actually discover, profile, and configure top-of-rack network switches through Virtual Machine Manager or through System Center. So we have the standard called OMI, which we are actually working on a bunch of partners with. You will see actually a demo later of this that we've done with one of our top-tier partners called Arista. But basically, it allows a level of control. It allows a level of control while continuing to enable that standards-based approach that we are taking and simplifying how you can provision and configure network gear. But this is just one example, and it shouldn't be any surprise that that's how we do it in our global data centers as well, right? We've got these standardized networking gear that actually talks and works with our products like Windows Azure, and we are bringing that, again, into our products like Windows Server and System Center 2012 R2. So at this point, I wanted to hand off to CJ, but hopefully you will see how our investments in R2 and going forward will continue to tie with these three key principles that we have here while ensuring that we meet these promises around flexibility, automation, and control for you. Thank you.
Thank you, Anant. So what I want to do is I want to go through those, I'll back up a second, go through these key technologies that Anant talked about and go into a little bit more detail about how they work together, especially towards the end, talk about how then SCVMM actually manages these technologies. And kind of throughout, I'll show a few demos that I think are pretty interesting. So the first one that I want to start with is Hyper-V network virtualization. Let me see, how many people are aware of Hyper-V network virtualization? Okay, so it's kind of mixed, about half and half, I would guess. So, as Anant had said, with Hyper-V network virtualization, the concept is fairly similar to virtualization in the server space. So you have a set of resources in the server space on the physical host, and those are replicated to the virtual machine. And Hyper-V network virtualization works on a similar principle in that you have a set of resources that are available in the physical network, but you want to abstract those away from the actual application such that you can have multiple virtual networks running on the same physical network. And we do this through a technique called overlay networking. And basically how this works is you have these sets of virtual networks, and they're overlaid on top of the physical network using packet encapsulation. So when you look at the actual packets that are going across the wire, you have essentially two packets in one. You have the outer packet, which is what goes across on the physical wire, and then you have the inner packet, and I'll talk a little bit more about this, but you have the inner packet that is actually the packet that the virtual machine sees, and that's the one that they process on. And this encapsulation, we use a technology called NVGRE, or Network Virtualization Using GRE. And GRE is an industry standard way to encapsulate packets. And so we've built on that industry standard way with NVGRE to produce this overlay networking. And the two big problems that Hyper-V network virtualization solves is, first, it solves VM mobility. So you're no longer constrained by your physical network, and basically I can only move my VM without reconfiguring my virtual network across the same L2 domains. Now you don't have those limitations. You can actually migrate your VMs anywhere within your data center and have it automatically continue to communicate. The second one is that it allows customers to bring their own IP addresses and own network topologies, both in a hosted environment and in an enterprise environment. In a hosted environment, it's pretty simple. You have multiple customers that come in. They might have their existing IP addressing schemes or their existing topologies that they want to bring with them. And so here, we enable the hoster to be able to do that with these virtual networks because they're securely isolated from each other. As Ananth said, we don't have limitations like VLANs on only 4,096 virtual networks. If it's 24-bit identifier, so there's millions of networks that you can create, which is typically enough for most people today. A lot more than 4,000 for sure. But even in the enterprise space, we've seen a lot of interest in this because you can imagine the scenario where you have both a production and a test and maybe even a pre-production environment. And instead of having to run them on separate networks or having to slightly change the IP addressing scheme or the network topology so that they actually work together, you can now, with virtual networks, run them all on the same physical network using the exact same topology, exact same IP addressing scheme, because it's all inside a virtual network. And as I said, you can do this all on the same physical network. So we think, especially when we look at kind of the flexibility aspects of SDN, Hyper-V network virtualization really helps solve a lot of the flexibility issues that you get with, or that you would have with only using a physical network. So let me just talk a little bit about how Hyper-V network virtualization works. So in the top, we are seeing kind of what the customer sees. So the customer has, two customers. They each have a SQL server and a web front end. Pretty simple setup, but it's a fairly common setup. But what's actually happening is both of these customers are going to be running on the same Hyper-V host. And as we build out, what we see is, we see Contoso comes in, and they have certain IP addresses, 10.1.1.1 for the SQL server and .2 for the web server. And so those actually get pushed out into the customer address space. But then with this NVGRE, this overlay technology, you also have the provider address space, which is what the physical infrastructure actually sees. So the VMs only see that they're, assigned this 10.1.1.1 or .2, but actually the hosts that they're sitting on top of have a different IP address that they've been assigned. And so when so in this this NVGRE packet, basically both of these IP addresses come through. And so the physical one is used to actually transport it across the physical infrastructure, and the customer address one is used to actually communicate between the VMs, and it all comes across in the same packet. And what it allows is that once Fabricon comes in with the exact same IP addressing scheme, they like these IP addresses for some reason, that they can actually be placed on the exact same machines, and it all just works seamlessly. And so this is, it really allows a lot of flexibility in how your IP addresses are handled, how you move machines, because these VMs could also move between each other, between this host or between a host on another rack in a different L2 domain. It doesn't matter. They can continue to communicate because of that separation of the actual customer address that they see and the provider address that is seen by the physical infrastructure. So let me talk about some of the new features that we delivered in 2012 R2, because in each of these areas that Ananth talked about, we did deliver some big new areas, but we also enhanced all of our existing areas. So one of the big pieces of feedback that we heard in 2012 was the fact that with virtualized networks, that you couldn't make the host or the guest use clustering. So you couldn't necessarily make them highly available. And so we enabled a feature that allows us to dynamically learn these customer addresses And that gives us the ability to support both guest and host clustering. And so not only can these inbox gateways that Ananth talked about be highly available, but also any VM or any host that's running inside these virtual networks can be highly available. So we think that's a big feature where you kind of, you don't lose anything by moving to the virtual network. The other thing that this allows is the ability to run DHCP server directly in the virtual network. So being able to, without SCVMM, still get dynamic IP addresses in the customer address space. So this was kind of two big areas, or two big features that were enabled by this. The other thing is that we've done quite a bit of work around performance improvements. So the first one is NIC teaming is a mechanism by which you can essentially have a set of NICs, 2 or more NICs, and team them together so that they look like one NIC to the host and to the VM. And in 2012, while the failover portion of NIC teaming worked, the load balancing portion didn't work in a virtual network. So you didn't get the ability, let's say, if you had two 10-gig NICs, to use all 20 gigs that were available. With 2012 R2, you can now get that full bandwidth that would be available inside the NIC team. And then also, Dhananjay will talk more about this in the partner section, but one of the things with NVGRE is that a lot of the NIC offloads, things like large send offloads and whatnot, don't necessarily work with NVGRE traffic. And so now we've worked with partners to actually enable that NVGRE packets to work with the task off or the same NIC offloads, so that you can get the full line rate performance that the NIC would provide. And like I said, Dhananjay will talk more about the partners that we've been working with on that. And then the last thing is we've added a lot of diagnostic capabilities, and I won't go into too much details around this, but as people are now starting to deploy the virtual networks, we hear a lot of feedback that says it's not particularly easy to debug certain scenarios within the virtual networks. And we delivered quite a few enhancements to the diagnostics capability. And I have a deep dive session on Hyper-V network virtualization on Thursday that I'll go into more details on the kind of diagnostics that we enable in 2012 R2. So that was the first, Hyper-V network virtualization, really about flexibility, really about allowing customers to move VMs, bring their own IP addresses, whatever they need to do. So the second kind of big technology area that's part of our SDN solution is our Hyper-V extensible switch. And I think, how many people are familiar with the Hyper-V switch? I mean, I imagine almost everyone. So I won't go into too much details about this. But the virtual switch provides all the layer 2 connectivity between VMs, whether it's the VM to the outside world, VMs to each other, whatever L2 connectivity needs to happen. That's done by the Hyper-V switch, and it comes with a lot of capabilities, isolation, traffic shaping, and those are kind of the built-in capabilities. And what it really allows us to do, and as you kind of think about it, it brings the physical network all the way to the edge of the host. And so now the host with the Hyper-V switch is actually participating essentially in the physical network itself. And it allows us to do a lot of things that you wouldn't necessarily be able to do without this intelligence actually running on the host. But one of the big features that we enabled in 2012 were these things that we called switch extensions. And what this allowed was third parties to extend the capabilities of the virtual switch. And so one of the things that we looked at in 2012 was that even though a lot of capabilities were built in, we knew people would want to extend kind of the capabilities of the virtual switch. And what we've done is we've added a number of extension types. So we have capture extensions that allow third parties to capture all the traffic that's coming through the virtual switch. We have filtering extensions that allow third parties to filter the type of traffic that's going through the virtual switch. So you can imagine things like firewalls being built with this capability and being integrated directly into the virtual switch. And then last, we have these forwarding extensions. And this is where basically a third party can come in and modify how a packet's forwarded. And here, some examples of partners that we have in each of these areas, particularly the forwarding extensions. We have the Cisco Nexus 1000V switch extension, which they announced earlier this week was going to be generally available. And so, this allows the Cisco or the Hyper-V switch to be managed by the same management tools that manage the other Nexus physical switches. And so you have one management solution across both physical and virtual. And then NEC is another partner that came in and built an OpenFlow switch extension. And so just like they can with their physical switches and being able to manage their physical switches with OpenFlow, when you install their OpenFlow switch extension, you can now manage the Hyper-V switch with OpenFlow semantics. So it's a lot of ability to come in and have tight integration between physical and virtual switches for a particular vendor. So we think this has a lot of capabilities. But one of the things that wasn't supported in 2012 was that Hyper-V network virtualization, because of where it was built within the stack, you couldn't actually run these third-party forwarding extensions and run Hyper-V network virtualization. And so what we've done is we've essentially moved the Hyper-V network virtualization filter into the virtual switch itself, which now allows this new hybrid forwarding mode, where for Hyper-V network virtualization packets will be forwarded by the H&V filter, and non-H&V traffic will be forwarded by the third-party extensions. And on top of this, it allows extensions to see for network virtualization traffic both the physical packet that's going across the physical wire and also the customer address packet, the one that's seen by the VM, whereas before they could only see what was seen by the VM. So it allows kind of much richer capabilities within the switch extension itself. So what I want to do now is I want to show a demo, and let me switch over to the demo machine. I want to show a demo of the Cisco Nexus 1000V switch extension, and actually what I'll show here is where it's coexisting with Hyper-V network virtualization. So let me log in. Yep, looking good. So I'll talk more about System Center Virtual Machine Manager in a little bit, but I'll kind of go through some of the concepts here. So basically what we have is we have what's called a logical switch. And this logical switch spans across a number of hosts. And so when we go and look at this logical switch, one of the things that we can see is that there's been a switch extension installed on this particular switch, which is the Cisco Nexus 1000V. And I thought I clicked on it. So if we go to extensions, we can see here that the Cisco Nexus 1000V switch is installed. We can also go in and see a couple of logical networks that have been created. And in this case, what we're showing is both an H&V network and a VLAN network. So, VLAN network would be kind of your traditional network with non-virtualized traffic. The H&V network would have all the network virtualization traffic running over it. And then if we come down, we can see inside the VMs and services that we have two VM networks, one being the H&V network that's assigned. This is not moving up, but you can see two networks, the H&V coexistence network and then the native coexistence network. And then on the host itself, you can see that we have hosts we have a host with two VMs, one on the virtual network, one on the physical network. And so what we can come and see, so all this is being managed by the Cisco 1000V switch extension. And so here we can show the coexistence of both. Well, that wasn't supposed to happen. Okay, so okay, now it worked. So basically what I'm doing is I'm doing a large file copy. So I'm going to copy over VHD. I think it's working now. Let me switch over to the other machine. We'll see if we get red there. So we're doing a large file copy both on the virtual network and the physical network. Let me see. Okay, well, we'll see. I think this is working. Normally I wasn't getting red. And so what we can see is basically what we can see is we're receiving traffic on both the virtual network and the physical network at the same time. So even though these are running on the same host, we're getting both type of traffic, and where the Hyper-V network virtualization filter is forwarding the H&V packets, and the Cisco Nexus 1000V switch extension is forwarding the non-virtualized traffic. And so just, here we can see the packets incrementing, and these, in this case, are GRE packets, so you can see that it's all working. Okay, so let me switch back to the slides. So I think that shows kind of the power of the switch extensions and being able to have the capability of being managed by the same management as your physical infrastructure, but also using the enhancements of Hyper-V network virtualization at the same time. Sorry about that. So the next thing that I want to talk about is the built-in gateways. And so as Ananth mentioned, we got a lot of feedback that while it was great that we came out with this Hyper-V network virtualization, and it was great that we're working with partners on building these gateways, there really needed to be something in box so that people could pick it up, evaluate it, get it working in small environments, making sure that it's kind of met their needs before going to full production. And so what we've done is in R2, we're shipping a number of capabilities in these software gateways. So basically 3 main capabilities. So the first is VPN site-to-site gateway, which allows you to communicate using VPN over a tunnel between data centers. Also, we have a NAT, which allows you basically for internet access or to basically NAT the machines that are in the virtual network. And then also a basic forwarding gateway that really just does the encapsulation and de-encapsulation of the packets and allows you to communicate from your virtual network into the physical infrastructure, physical machines in that same data center. And with all of these gateways, they're what we call multi-tenant aware. So within one VM, you can support multiple tenants, and those tenants can all have overlapping IP addresses. So this is a new capability that we've added into Windows for these gateways, is the ability within one VM to support multiple routing domains, is what we call them, where in each routing domain you can have overlapping IP addresses, you can have whatever network topology you want, and that Windows VM can communicate across these. And basically how it works is in the networking stack, we have different compartments for each of these tenants. And each of these compartments are completely isolated from each other. And so how they route is specific to the compartment, not specific across the VM or across the Windows machine. And so it allows us to support these multiple tenants. The other thing is that even though we've built in these capabilities, we still see a lot of room for partners to come and build these gateways. And so what I'll do, and Dhananjay will talk more about all of the partners we have in the gateway space. But what I do want to do is I want to show another demo, which is, actually let me switch back. So what I want to show is F5 software-based Hyper-V network virtualization gateway. So this was something that they announced this week, I believe, just recently. And this gateway, they're basically big IP virtual load balancer. So it just comes in with their big IP virtual appliance. And that's what they've announced and is available today. And then they also announced that their hardware big IP will come with the same capability in Q1 of 2014. And so not only will you be able to get it within their software appliance, but also their hardware in Q1 of 2014. And basically what this allows you to do is two things. It allows you to bridge between these virtual networks and the physical networks, and then it also brings all their load balancing capabilities so that you can directly load balance. So you can have essentially a VIP sitting on the physical network, and then it can distribute the load to VMs that are sitting within the virtual network. So if you have a web farm that's sitting within the virtual network, they can directly load balance and bridge between the physical and virtual network. So it gives you the ability to really bring your network or bring your VMs into the virtual network while still having them accessible by the physical network. So let me switch over and I'll show a few pieces of this. So what we can see here, let me actually switch over to the fabric real quick. So what we can see is that we have the F5 Big IP and VGRE gateway, and it's a gateway that's installed into VMM, so VMM can use this when virtual networks are created. And what we can do is we can also go in. We can go into the VMs and services, and we can see within the VM network that we have a couple of VM networks already created. So we have this accounting network and this marketing network, and we can see that they're both using the same IP address range, 10.10.10.0. And if we go into the configuration of these, we can see that the gateway that they're using is this big IP gateway, which has the address of the .1. So let's go over to a couple of the machines that are actually running and inside the virtual network. So these are inside the virtual network, and we have the big IP gateway sitting in front of them. And we'll just do a simple test. We'll come in and we'll see that these machines can get access to the physical network. So they can go out to Bing.com or whatever your favorite search engine, which should be Bing.com, but whatever your favorite search engine is. And then we can also see, on the other machine, so this is in a different virtual network, but on the same physical host, we can see, essentially the same thing, that you're able to go out. But then also what you're able to do, as I mentioned, was that you can set up a VIP from a physical network. So this is the host machine that I have right here, and I can go out to a VIP that they have that's sitting in front of those two virtual machines in the virtual network. And so now it can load balance across them, and you can actually bridge that physical and virtual network. So, and then the networking for this is, essentially I have a physical machine, and it's hopping through a VPN connection to the big IP into the virtual network. So it's a fairly complex network, and it just works. So we think that's an exciting product from a partner, and really fills in the gap of being able to load balance inside these virtual networks. So the last area, or the last kind of core technology that I want to talk about is this network switch management. And so basically, the idea behind this is pretty straightforward. Microsoft uses a standard SIM-based model for managing a lot of our compute and different parts of our infrastructure. So the virtual switch is used by the SIM schemas, and this is what WMI uses to actually communicate between the devices. So we have this standards-based SIM model that we've worked with in the DMTF standard to produce for physical switches. And these switches are running this open management infrastructure, OMI, piece of technology that we've open sourced that allows basically hardware devices to more easily integrate with these SIM schemas. And then we have, on the Windows side, we have a set of PowerShell commandlets that can actually communicate with these switches. And so, basically the switches add in OMI and the providers that are needed to actually manage the switch. And then we have the PowerShell commandlets running on Windows, and it's all communicating with WS-MAN, so kind of the standard way to do it. And in this, between both SCVMM and PowerShell, this gives you a lot of capability to automate regular tasks that you would do with your network infrastructure. And it also allows, across multiple vendors, a common interface to actually go and manage these devices. And in 2012 R2, we'll have a logo program for these network switches so that that, if they're logo certified, that they can work with all this, work with the management infrastructure around OMI. So what I want to do now is I want to demo basically this functionality working with an Arista switch. So let me switch over to my Arista demo. And so Arista's announced the availability of this functionality. It comes with their latest EOS release, so it's actually going to be available across their product line. So it's not one particular switch or one particular product that's supported, but it's actually going to be across their product line. So as soon as you update to the new version of EOS, you'll be able to get this capability across any Arista switch. So it's a fairly broad amount of devices from Arista that will have this functionality. So basically what I'm showing here is, it'll be a fairly short demo, but what I'm showing is the ability to kind of enable and disable VLANs and ports through PowerShell. There's another session coming up after this one, I don't think in this room, where the SCVMM team will show the integration of the Arista switch into SCVMM, but I want to kind of focus on it from a PowerShell perspective. So here, just as an example, these are the kind of commandlets that you might see. Disable switch Ethernet port, enable switch Ethernet port, stuff around VLANs, being able to get switch information. And so what I'll do is I'll run through this and basically show this working. And this is running against a live Arista switch. So what I can do is I can, get Ethernet ports, and basically I'm saying get number 1 and 4, and these we have a couple machines attached to. And so I can do a couple what ifs. This is functionality that's in PowerShell, where you can run a command and say, what if I run it, to see what will happen. So it tells you what happens. Now here I see what will happen. I say, okay, now I want to go and do this. I want to go enable the Ethernet port. And I want to set the VLAN access mode to 1. So I want to set a VLAN on each of these ports. And I come in here, and I'm going to, don't do this by putting your password in a PowerShell command like this, but doing a demo is pretty safe. So I will run testnet connection on this. And what we should see is that the connection will succeed. So hopefully. So we can see that we can now ping between these two machines. So now what I'm going to go in and do is I'm going to go in and disable the first port. So I'm going to disable port 1. And so now I'm going to rerun testnet connection. And hopefully it should fail. This is the one time you actually want PowerShell to fail. So this failed because we disabled the port, so they can no longer communicate between each other. So what I'll do, just to, for the fun of it, I'll come back and enable this port as soon as PowerShell comes back. So I'll enable the port. And basically what this is showing is the ability to, through PowerShell, to programmatically manage your switch now. And there's a lot of kind of richer capabilities that you can do outside of just this, but just for the basics. And give it hopefully the 30 seconds it needs to get everything working again. And what we should see is now we've enabled it back, and maybe one of these pings will succeed. I didn't talk long enough. That was my problem. It takes about 30 seconds to get the port and the connectivity back up fully. So we can try it one more time maybe, and hopefully it'll work. Okay, maybe not. It works though, trust me. But this shows kind of the capabilities that you have. And just as an example, with PowerShell, you have the ability to write functions. So, maybe this is a fairly common function that you want to do. You want to enable ports and disable them. And so you can, through PowerShell automation, you can actually come and write functions that will do this over and over again, really providing you the ability to automate this network management. Okay, so let me talk about one last thing after this, is kind of how SCVMM fits in the picture. So, we talked about Hyper-V network virtualization, we talked about the extensible switch, we talked about the built-in gateways, and we talked about switch management, which, each of those kind of really focus on flexibility or control. But now, a big part of the SDN promise is being able to automate all this, because, while it's great to have control, while it's great to have flexibility, if you have to do it all manually, you're just going to mess it up, most likely, right? Because if you do kind of these type of things and you're having to type in, the commands every time and set it up manually, it's just not going to work very well. And so what SCVMM provides is really the automation on top of these technologies. And so when some of the kind of key technologies that, or key concepts within SCVMM, and I've touched on them briefly in both the Cisco and the F5 demo, but there's this concept of a logical, or you have your physical network. And then there's this concept of a logical network that's sitting on top of the physical network that provides SCVMM a representation of the physical network. And then on top of it, you have the virtual switch, which is sitting on each of the hosts. And SCVMM can go and manage each of those virtual switches and also manage any switch extensions that are supposed to run in that virtual switch. So the switch extensions that I talked about are all manageable through SCVMM. And then sitting on top is you have this VM network concept, which is this virtual network. And so you can have multiple of these, essentially one for each tenant or one for each network that you want to create. And these abstractions allow SCVMM to go in and automatically manage this capability. So for instance, you can create a logical switch, which spread over many different hosts, and you set the configuration for that logical switch, and now SCVMM will automatically push out and configure that virtual switch in the way that was specified. So instead of having to go to each individual host and configure it, now you can create one configuration and push it out to every host that you want it to be in. Or if you want to reconfigure it, you can reconfigure the logical switch, and SCVMM will automatically go out and reconfigure it across. Or from a VM network perspective, you create a VM network, you say, I want to attach these VMs onto this VM network, and you have it all running, everything's going well, but now all of a sudden you want to migrate one of those VMs. Well, you don't want to migrate the VM and all of a sudden lose connectivity, right? And so SCVMM, because it knows it's going to migrate the VM, it knows it can migrate it and then migrate all the policy with it, and so the connectivity is seamless across that VM migration. And so it really gives you the ability to do things at scale that you wouldn't necessarily be able to do otherwise. And so, so I talked about the logical switch and the network policies moving with it. So, it really gives you that automation that you wouldn't have without it. And so what I want to do is I want to show a demo of kind of some of the concepts around SCVMM. There's more detailed deep dives of SCVMM coming up, I think, the next 2 set of sessions. And so I'd encourage you, if you want to learn more about SCVMM, to go to those sessions. But this will give you kind of a flavor for what it looks like and some of the capabilities. So let me actually jump over to this one. So what we see here, kind of a few key concepts here, is within the fabric you have these logical networks that I talked about, which provide you the representation of the physical networks. You also have these logical switches that you can define and create that have sets of properties across it. So this is where you say, I want this logical switch to have these set of extensions and this configuration across it. You can also have network services and gateways that are defined and usable by the VM networks and whatnot. Then you can come into the VMs and you can see, the big thing that I'll kind of focus on is the VM network. So you can, have gateways, you can attach them to VM networks, you can have hosts and VMs, attach them to these VM networks, and then you can come in and create these VM networks. So let me maybe try to create a new VM network. I guess over here, yeah. So I probably won't go through all the creation, but just to kind of show you an example. So, well, I'll create a new, maybe we'll have the TechEd network, VM network here. You can say what type of isolation that you want it to use. So here we want to use Hyper-V network virtualization. One of the things I didn't mention, but Hyper-V network virtualization works across both IPv4 and IPv6. So full support for both protocols. So you can choose what you want to use. You can also decide what subnets that you want. So you can, give it a subnet. In this case, you can use the same one that you had before. Because this allows for the overlapping IP addresses. In this case, I don't have a gateway configured to use it, so you'd only be able to communicate with inside the virtual network, but I can always come back and add a gateway later. So this allows you, to create these VM networks pretty much on the fly. Like I said, I won't create it kind of for time, but then also in here, we talked about the gateways, and VMM will come with templates for these gateways. So you can actually see, you can configure the gateway in different ways. So in this case, I'll have a couple NICs, one to the infrastructure network, one to the external network, because it provides that bridge. You can come in and say what roles. So you want RAS to be installed, or you want NAT capabilities. You want to configure different things, and you can do it all through these templates that SCVMM comes with. So this kind of gives you a flavor of what SCVMM provides for the automation aspects. There's a lot more that I could go into. There's 2 whole sessions dedicated to it. So I won't go into any more details, but gives you kind of an overview of what's there. So now I want to pass it to Dhananjay to really talk about our SDN partner ecosystem.
Thanks, CJ. Hello, everyone. I'm Dhananjay Mahajan. I'm a senior program manager lead on the partner engineering team. And my team's role is to help out partners build end-to-end solutions that we can deliver to you customers. And today is a special day for 2 reasons. One is, as my peers told, there's a whole ecosystem of partners that we want to showcase to our customers. So you have a choice of solutions that you can build. And secondly, today is my 20-year wedding anniversary. So you may question the priorities in my life when I'm here talking at TechEd with you. So as CJ and Anant pointed out to, we have solutions that we have built in the box with our inbox controller. But we realize that our customers have other capabilities that they want and innovation that our partners have built. And we want to make our solution, our platforms, extensible so that partners can build on an open, extensible, and standards-based platform. Using that, we have partners who have built vSwitch extensions that CJ demoed. We have also partners who have built NVGRE-aware hardware task offloads, which make the entire solution much more performant, all the way from switching ASICs as well as to network adapters, which have these capabilities. And then HNV gateways. We demoed the F5 gateway just now with CJ, but I'm also going to show you a video later on of the Huawei gateway. And then with management, with our data center abstraction layer, we are allowing partners to build in standards-based management through the OMI capabilities that we build in through SIM-MOM profiles. So a whole ecosystem of partners that we have put together, starting from gateway appliances, as I talked about F5, who was built through their big IP platform, ability for applications to reserve, directly monitor, and secure resources. And that solution is going to be available first quarter of 2014. We also have gateway capabilities that were announced by Iron Networks and Iron Systems at MMS, and they're further enhancing those capabilities in the coming months. I'm going to show you a quick video, as we couldn't do a live setup of the Huawei gateway. We have Arista, which CJ was demoing, and Arista through the EOS version 4.1.2 platform is making all their devices manageable through OMI. Then we demonstrated Cisco and NEC's OpenFlow capabilities. Cisco, which has announced their Nexus 1000V earlier this week at TechEd, and then NEC, which has the PF1000, which is also being enabled through and enhanced through System Center Virtual Machine Manager. So our customers can get a single pane of management through System Center to manage all these capabilities. And we have other capabilities with F59 and InMon, which can do monitoring and security, but also in the ASICs. And I'm going to talk to you about some of the enhancements that some of our switching ASIC partners have done with Mellanox and Emulex. And tomorrow I have a session with Intel, so please come to that session early at 8:30. We'll talk about the innovations Intel and Microsoft have done together. So talking about Emulex, Emulex has VNex platform, which has task offload capabilities. And some of the latest numbers we've got from them with no NVGRE task offloads on the left and optimized NVGRE task offloads on the right. We've been working very closely with them to get more and more performance enhancements. And then with Mellanox, we have the ConnectX-3 Pro 10 GB Ethernet showing great performance in terms of throughput with better performance with the ConnectX-3 through NVGRE, and also lowering the CPU overload when you have the NVGRE capabilities turned on with the offload capabilities in their platform. So as you can see, using some of the performance enhancements that our partners bring in, you can get better scale, better performance out of your solutions on top of the Microsoft platform. And then I wanted to do a quick demo of the, as a video, because we couldn't get the whole live setup working, of the Huawei Cloud Engine 12800 series that will be available at the end of this calendar year. And this demo goes through a quick experience of how easy it is to set up a plugin. Huawei has written a plugin for Virtual Machine Manager, which allows you to manage their gateways. So it goes through the experience of showing you that first there's no gateways when you launch the VMM console. Then you register the gateway plugin using the gateway APIs that we have. Then it allows you to actually initialize the gateway, discover the gateway, also create VM pools, and as CJ was showing you, create a VM, attach it to the VM pool, show you that there's no connectivity, but as soon as you have turned on HNV, you'll get connectivity through that end-to-end. So using the capabilities that you've seen in terms of the extensibility of the platform, we allow you to get additional solutions, whether they are through the gateway plugin in VMM that can allow you to expose the gateway functionality through VMM, so our customers have a single pane to manage all their devices. Whether it's through OMI, so you can manage the switches using the OMI capabilities that will be available in the platform, or they are through vSwitch extensions, which allow you to either do filter extensions, forwarding extensions, thus providing you a whole range of solutions that are possible on the platform. So about 8 or 9 of our partners have actually come together, and I thank them, together at TechEd and actually making announcements for their solutions, which are available, some of which are available today, and some of them will be available with Windows Server 2012 R2 being released pretty soon. So with that in mind, okay, so we still have the demo going through. As you can see, that's the Huawei VM network. You create an IP pool, give it a name as Blue VM pool, assign it the IP addresses. Now we have the VM Blue Network. Now let's create a new VM. We have pre-assigned VM images that we'll pick up. The IF. Go off. Okay. Is that a hint? Am I done? And then when you initialize the VM, you'll first see that you have no connectivity. Give it an IP address pool. So now we start up the VM, and if you launch up the VM, it will show that you do a ping on the address, you don't get connectivity, and the ping fails. But then you turn off the VM again, and then you restart it. While this is going on, let me talk to you about the key takeaways. Deploy Windows. Go out and deploy Windows Server 2012, because 2012 R2 is also coming up, and also System Center 2012 SP1. This is available today, and you can start leveraging the capabilities of a very flexible, open, standards-based platform. Evaluate this. Preview bits for Windows Server 2012 R2 and System Center 2012 R2 are coming soon. So with this next release, we are aligning System Center and Windows Server so you get a complete end-to-end platform and a solution that's manageable. And this ping has got to succeed. So as you saw, there we go. So in summary, Microsoft will continue to build more and more innovation into the platform in order to use our learnings and give you, as the customer, the learnings of running large-scale cloud services for your data center. Microsoft's SDN promise is about network flexibility, automation, and control. And Microsoft provides the open, extensible, standards-based SDN solution platform. So we will bring you more and more partner solutions to help your diverse needs, and we'll continue to extend. So come to TechEd Europe. You'll see a few more solutions coming on board, and even during launch. So thank you for your time. And instead of taking diamonds to my wife, I'll probably take a few network appliances, because we have the partners who are building them with us. Thank you.